Ma, ang init. Buksan natin yung aircon.
Ayan ka na naman. Ang taas-taas ng kuryente natin. Magtiis ka.
Do you feel the heat of the air? Do you want to be chilly without worrying about high electrical bills? Are you looking for sustainable and renewable source of energy? Then it's time for you to be introduced to Dye-sensitized Solar Cell. Well, DSSC is not only for our low-cost electrical bills. By using this, we are also contributing to our environment, as the DSSC are made from non-toxic materials such as organic dyes, making them more environmental friendly compared to other energy sources. By using natural dyes, we are able to create solar cells that are more sustainable and eco-friendly without sacrificing performance. Plus, papaya seeds are readily available and affordable source of natural dye, making this technology accessible to all people all over the world. The papaya seeds can contain a natural pigment called carotenoids, which can be extracted and used to create a dye that is highly effective at absorbing sunlight. This dye can be used to create a DSSC, which is a type of solar cell that is more efficient and cost-effective than traditional silicon-based solar cells.
The papaya was bought from retail market, Tondo, Manila. While the indium-doped tin oxide glass and titanium dioxide were purchased in an online shop, for the multimeter, it was bought from hardware. The natural dye sensitizer was prepared using papaya seeds that were washed with distilled water, dried at high level power in a microwave for 7 minutes, and then grinded into small pieces. 10 ml of ethyl alcohol was added to every 1 gram of grinded seeds, and then stored for 24 hours. For the paste, 1 tablespoon of titanium dioxide was mixed with 1 tablespoon of white vinegar and 2.5 teaspoons of liquid detergent until the thicker than water but thinner than paste consistency was met. In assembling DSSC, the conductive side of indium-doped tin oxide glass was tested using a multimeter and then cleaned by tissue with ethanol. A scotch tape was used to make a 4-sided border around the glass, then a small amount of paste was spread. After the paste was air-dried for 10 minutes, the scotch tape was removed and put in an electric stove for 12 minutes. Then the extract of papaya seed was placed right on the top of the cell, leaving it for 5 to 10 minutes before the cell is rinsed with distilled water and ethanol. For the counter electrode, another piece of ITO's conductive side was passed through a lit candle several times, building up a layer of soot. Using a cotton swab, the soot from the edges of the glass was removed, then it was placed offset and clipped in the dyed cell, and 4 drops of betadine were dropped on opposite edges of the glass. The DSSC was tested with the use of a multimeter to determine the mean amount of voltage produced when exposed to a 2101 min lumens LED bulb.
The DSSC extracted from papaya seeds generated 0.4 voltage under 2101 min lumens LED bulb. To conclude this research, the natural dye extracted from papaya seeds has the potential to be used as a photosensitive organic dye for DSSC as it produced 0.4 voltage when tested under the light. The researchers suggest testing the natural dye with a spectrophotometer to see how effective the chosen dye's properties are. The researchers also recommend experimenting with the fabrication, which can include using different methods and parameters to optimize the device performance, varying the dye concentration, thickness of the dye layer, type of electrolyte used, and the counter-electrode material. The stability of the devices can also be tested under different conditions such as temperature, light intensity, and humidity.